I'm Hugh. I've come from the planet 581b. See you faffing around with windmills and the like. And in a desperate attempt to solve your energy crisis. So we have come with pity to show you a much more sustainable solution. Today I'll be talking about energy and space exploration. In this presentation we will cover, number 1, why to explore space. Number 2, the cost issues of escaping from Earth. Number 3, facilitating energy economic long-distance transport. And fourthly, energy resources in space. Number 1, why explore space? First reason, time and time again we have seen in the history of humanity, people who have not invested in space exploration have been left behind. Number 2, there are more and more people coming into the world, approaching or already reached 7 billion and 9 billion by 2050. Less and less resources. Instead of squibbling over what is left and fighting over that, I suggest that we make use of the abundant resources which are available with technologies we have already developed and technologies which humans can develop in the near future. Some practical applications from NASA's projects, a huge amount of practical technologies have been developed. Right, let's get to the nitty-gritty. Escaping Earth. So step 1, we need to get out from the Earth's surface to near Earth orbit. You've been unfortunate in that Earth lies in the bottom of a relatively deep gravity well. Also, you need to fight against air resistance. So the conventional way we do that is with very powerful rockets, brute force. Saturn V, the biggest rocket ever made, is incredible amounts of power. Saturn V produces up to 124 Boeing 747s running continuously, leading to 86 This is a brute force approach. This is the only way humans have managed to escape. However, there's a fundamental problem. I looked at Saturn V and added up the total mass of fuel in Saturn V. Turns out it's 90% of the total mass of Saturn V. You're using most of your energy in lifting up the fuel to get you up. That leads on to a very clever solution. Now this is very controversial and you humans may not think this is feasible. The space elevator. The idea is to extend a cable between the surface of the Earth and just outside, just beyond geostationary orbit. It will be held in tension by the centrifugal forces caused by the spinning of the Earth. And the climbers, as you can see here, which are moving up and down, would be powered by a remote source on Earth. So the electricity will be generated on Earth and beamed up to the climber via a laser or microwave beam. You don't have to lift up the weight of the fuel itself, so you save a huge amount of energy. So you only have to lift the potential difference in mass. Now this was never seriously considered until about 10 years ago, or less than that now, when graphene was discovered. Because before that there was no material which could withstand the tensile loads and this cable would require. Just to make it clear, this is not science fiction. This is being published in scientific journals today. A huge amount of research and interest is in the idea of a space elevator. Let's say that we can actually get material into space. You can, but let's hope the prices will go down, and they will continue to go down. Then what? Where next? How do we propel beyond there? Well, we've gone out of the gravity well of the Earth, and we don't have to fight air resistance anymore. So we are somewhat fortunate. You can travel very significant distances because you don't have much resistance with very little fuel. However, you are very far from anywhere to lift up. So the main propellant which is used at the moment is hydrogen. But if you really want to make significant distances, there are 2 technologies which are currently being considered by NASA. Fission fragment rocket engines. But the idea here is on Earth you need to have thrust for a long period of time continuously to get you anywhere. Otherwise you don't go anywhere. Whereas in space, you can get away with having short bursts of very high power, very high specific impulse, because there's no resistance, that will give you the acceleration you need. The second idea, variable specific impulse magnetoplasma rockets, as you can show here. The idea is you heat up your gas, be it hydrogen or deuterium, to very high temperatures using electrical power generated by fission, until it becomes a plasma. The fusion plasma will be directed by magnetic fields, again generated by electricity generated by fission energy, to propel you forward. So any of these two ideas will massively increase the rate at which we can explore space. Using nuclear power essentially means very little amount of fuel can get you very far in a very long time. And these are technologies which are being used right now, even on Earth. In submarines you have nuclear powered reactors and ships. So this is not science fiction, this is what's happening right now on Earth. Next, what we want to do is we want to reduce, as I said, the amount of fuel that we take into space. Now, the best way we can do that is make available sources of fuel in space. Number one, the first step you will need to do is put these propellant depots in low Earth orbit. The next stage is to put it into Lagrange points, which we will demonstrate if Professor Shumo will help me out there. Basically, the idea is, when you have two masses, each having its own gravitational field, there will be points within the combined fields where, if you place an object, they will maintain in relative stationary position, which is very useful because you can put a fuel depot in these locations and they will not move. If you want to get to the moon, you've got a stopping point halfway. If you want to go beyond. Similarly, between the Earth and the Sun, there are 5 Lagrange points which we could station your fuel depots. We'll demonstrate the Lagrange points using this blanket. Can I have one more volunteer, please? You, female, come. This pomelo here, you need to put it tight. Very tight. Good. This is Earth. And this one over here will be, hopefully, the moon. No. No. Tighter, tighter. Go on. Good, 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 good. As you can see, I need something which is a board. There will be certain positions. Now, if we did this accurately, there will be 5 positions. There will be certain positions where, normally, if you put this ball, it will roll in to the gravitational field, which is no good. But there are, as you can see, certain positions. If I'm lucky, yes, they will not move. Which is very handy because this position here, we can put a propellant depot and reduce the cost of transporting fuel again and again. Right, that's all. You can leave now. Your servants are no longer needed. Next. Another very, very exciting idea. A very brave human started a £15 billion expedition, which is not in 50 years, not in 20 years, but in 7 years he will land on the moon and he will set up a processing plant to split the water on the moon and create propellant to facilitate long-distance space transport. He has created a company which intends to do this. Sheffield ice crater where has been discovered trillions of tons of ice. It's very easy. Once you're in space, you no longer have to worry about air resistance. You can fill up depots, huge big inflatable balloons, and you can fill them with the material you want and move them with relative ease. And it is hoped this will massively reduce, and it will massively reduce the cost of long-distance transport in Earth, which will encourage private investments in future ventures. There are trillions of tons of valuable materials which you humans are scrapping over on Earth and fighting over and warring over. Little do you know that there are trillions of tons of iron, nickel, gold, platinum, magnesium, cobalt just floating above your heads. A single asteroid can contain $20 trillion worth of valuable precious materials. And not only valuable precious materials, also materials which you can use as fuel for energy sources, oxygen, hydrogen for pellets, helium and deuterium for fuel sources, and of course, water which you pathetic humans need to survive. It is estimated that in the asteroid belt, if we extract the materials from there, there is equivalent of enough for $100 million for every single human on Earth. Why are you fighting over the petty resources which are left here? Conclusion. 1. Space exploration, yes, it's very energy intensive and it will cost a huge amount of money initially to get your propellants into space. Number 2, you need to invest in the infrastructure to economize the cost of long distance transport. Once you do this, the cost of moving materials will massively reduce and will enable you to extract huge, unimaginable resources from space. Then eventually you will have a net energy gain to Earth and you won't have to worry about silly windmills anymore. That is the end. Question?